So let's just write down some notes about parallel and perpendicular lines so you have them and you can reference back to them. So parallel lines are lines in the same plane, right? Meaning like we haven't talked about 3D space, so you don't really have to worry about this. They're lines that never intersect. Intersect is the official word, right? Cross is sort of the unofficial word, right? But intersect is a better word. So they're lines like this, and they go on forever, and they'll never meet. They'll always just run next to each other like this. And as you observed up here, they always have the same slope in different y-intercepts, always. So parallel lines always have the same slope. So examples in real life, a ladder, right? Like here's a ladder, or train tracks. The equal sign is two parallel lines. So those are some examples in real life. And so here are some examples of an equation, two equations that are parallel lines. So, and I'm just going to make one up. So let's say I make up this equation. In order to write an equation that's a parallel line, I would need to use an equation with the same slope and a different y-intercept. So those two equations would, if I were to graph these on a graph, they would be parallel lines. Now, perpendicular lines are lines that intersect at a right angle or 90-degree angle, and you should know both of these. You should know that that an angle like this, a corner, is called a right angle, and also it's called a 90-degree angle, and I didn't do a great job drawing it as a corner. And the way that we represent, like, oh, hey, this is a right angle, is we just put a little box in the corner. That's how we tell people that's a right angle. And so you should be able to use these interchangeably, though, right angle, 90-degree angle. Now, their slopes is a little more complicated. They're not the same. When you multiply their slopes together, the result is actually -1. And so just a few examples of that, right? If I have, like, for example, this, I'll use this and I'll show you. -3/2 times 2/3. Look what I get. -6/6, which is -1. Or here's another example, 2 and -1/2, right? Because that's 2/1. And then if I flip that, I get 1/2. And then they have to be opposite, so one of them is negative. So 2 times -1 is -2. 1 times 2 is 2. Again, this is -1. So you'll notice that anytime you multiply opposite reciprocals together, or negative reciprocals, and these are, you can use both. Negative reciprocal and opposite reciprocal mean the same thing, right? These are both okay. You get a -1, okay? And so examples like, I'm going to again make one up. Let's say I start with my 1/3 slope again. I'll start with the same equation. What's the opposite reciprocal of 1/3 or the negative reciprocal of 1/3? Well, I have to flip it, so that becomes 3/1, and I have to, this is positive, so I have to make it negative, and I'm going to simplify this, right? This is not the simplest way of writing it, so it would be a -3. So I need to write an equation with a -3 slope, and then I'll give it a different y-intercept. Okay, so those are examples of what would be perpendicular lines.